stress and strain. Now, stress and strain. Now, here today I am going to discuss that how that external load when applied to a body create an internal resistance, and this internal resistance is generated due to the mutual displacement occur between the molecule of the material, and that mutual displacement is known as a strain. So let's consider this is a body, and we apply a external load F. Now due to we assume that the length of the body is L, cross section is A agra, cross section angle length of the body is L, and elastic modulus that I am going to tell in the next chapter. Elastic modulus that is E. Now one more thing I want to tell that here I assume that material is isotropic. Material is assumption. Material is isotropic, homogeneous, equal strength in both tension and compression, equal strength in tension and compression, and we apply load within the elastic range. Load is applied within elastic region. So that material is isotropic. Isotropic means that if we consider any property, the property, if we measured in longitudinal or vertical direction, the value of the property will be the same. So the isotropic means that the property we consider here is invariable with respect to the direction. Homogeneous means that the property has the same value at every point of the material. So these 2 points is very important while we analyze the Hooke's law. In the Hooke's law, it is said that stress is proportional to the strain when the load is applied within the elastic region, that is up to the proportional limit. So Hooke's law. Stress is proportional to the strain. Now stress is equal to proportional limit is E. This is known as the elastic modulus. So this is the properties I assumed here, and this property is isotropic and homogeneous, and actually this simplify the analysis. Whole analysis it will simplify, and it is limited in the scope of our study, no problem in this case. So we can follow this without any issue. So now that the stress is equal to, here stress is equal to F by A. Now due to the applied force, let us consider that metal is assumed to take place in this position. Small lane changes occurred, that is L plus del L. So the strain will be del L by L, the change in dimension to the initial dimension, that is engineering strain. This is also engineering stress, means that the stress is calculated based on the initial dimension, or strain is calculated based on the initial dimension, is engineering strain and engineering stress. So now if we club together here, so we can get F by A is equal to E into del L by L. So we arrive in this formula, and this is very, we can calculate some solved examples to understand the importance of this formula, and it is also very important from the exam point of view, and this is regarded as a Hooke's law.